All right, so we've talked about mean, median, and mode for our measures of central tendency. Now we're going to talk about variability and standard deviations. Your variability is the amount of spread that you have in your scores. If I give everybody a 100-point quiz, it's important for me to know, did the student scores come back from 10% to 100%, or were everybody's scores 70% to 90%? Knowing how big that variability is very important for a lot of our statistical calculations. Some groups are naturally going to have larger variability than others. For example, if I were to poll the day students in the traditional day school at Drury about their age, I'm going to expect a pretty small amount of variability, right? Because most traditional day college students are between ages 18 to 22, 18 to 23, maybe 17 if they graduated high school early. But we expect a pretty small range for on-campus, full-time, day school undergraduate students. If I were to poll the online and evening Drury community about their ages, we would expect a much wider variability, right? Because we do have those that are the traditional age college student that online and evening works better for them for some reason. But we also have people who are going back to school, going to school for the first time, balancing career and family, whatever the reason may be. We have a much bigger variability in our age group. We use our variability, or our spread of scores, our spread of numbers, to calculate a statistic called the variance. And your textbook explains this pretty clearly. The more important thing, because we don't actually use variance a whole lot in statistics, the thing that we do use a lot is the standard deviation. I need for you to understand what a standard deviation is going forward for the entire semester. I'm going to break this down as simply as I can. The most simplified way to think about it is, okay, think of standard deviation as step, okay? Your standard deviation is the number of steps away from the mean that you are. What I mean by that is, as we look at our scores, as we look at our variance of scores, one of the things statistically we're going to look at is if we have our mean, how closely are those scored clustered around the mean? Like the example I gave at the beginning. Did the scores on my test range from a 15% to 100%, or did the scores on my test range from a 70% to an 85%? How closely around the mean were these scores clustered? A small standard deviation means that there is a small clustering around the mean. These scores don't go very far. A large standard deviation means I have a lot of variability in my scores, okay? So let's say that I had gotten an 80% on a test, and I knew that the mean score on this test was a 70. So my 10 points between 80 and 70. If my standard deviation was a 10, all right, so the mean's here. If my standard deviation was a 10, I am one step away from the mean. I am one standard deviation. I'm close. Let's say the standard deviation on that test was a 2, right? Most people scored right there near that 70%. So in that case, my 80%, right? I'm 5 steps away from the mean. They're smaller steps, but the standard deviation is a marker of how far you are away from the mean. This is going to become very important when we discuss z-scores next week. The concept of z-scores is only going to make sense to you if you understand standard deviations. And that standard deviation is how far away you are from the mean, measured in a way that takes into consideration everyone else's scores. So please read your textbook on that and try to reconcile my explanation with it with that. And hopefully that will become clear. And we'll pick up with part 3.